So today we will be talking about a very important kind of numericals, and that is when you cut into pieces. So this all the discussion today's will be based on cut into portions regarding numericals. Now this kind of questions comes in many uh, places like entrances, also for different exams. So basically today we will be dealing with a same problem, but we will be finding two different situation here. So we were talking about YOLO. Let's say a disk is there. The radius for the disk is r. So let me draw our radius. So this is r, and we have another circular piece which we are going to cut from this one. So we are going to cut this piece. So this is the piece that I am going to cut from here, and the radius for this one, so this is r, and this one is having radius r by 2, and the center of this blue circle which I am going to cut, so this circle I am going to cut from this yellow circle, and the center of this like blue circle is at r by 2 position from the origin. So origin is o, that means at origin point the coordinate we will be considering at 0, 0.0, like that. Okay. Acha. So basically this kind of problem, so this I am doing with disk, but generally it is applicable for rectangle also, rectangular pieces also, square pieces also, 3D shape also. So the concept is same, but the application will be little bit different. Now we are going to find the final center of mass, and also we are going to find the final moment of inertia. So these two things are two different questions, but here we are going to find these two things for the same problem. Now to start with this problem, first we have to understand something. Now let us talk about the first problem, which is center of mass. We know that center of mass is a point which represents all the particles in any object, and the what you say, the position for that center of mass is given by summation of mi ri by summation of mi. So that means not only the, let's say this is an object, so not only the mass, also the distribution from the axis uh, decides where my center of mass will be. Now let's say I'm talking about a very easy a very simple system of two particles. So this is my one particle, this is my another particle, this is m1, this is m2, whereas r is the distance between them. So if I find the center of mass for this, so let me take this as bigger. So if I write the, like if I try to find out the position for my center of mass, which I don't know, so let's say this is my 0 point, and from there I am center of mass is having a position, let's say r. So let's say this is my center of mass, and this is the distance r from the origin. So what I will write because summation means adding up. So m I r I, so first I will be 1 because I runs from 1 to n, the number of particle. So this will be m1 into r1. Now this is the beginning point, so the distance from this beginning point is 0, so that will be equal to 0, plus m2 and r2. Now you can see that r2 is this r, and then summation of mi, so that means it will be m1 plus m2. So finally I can write this as m2r by m1 plus m2. So this is the way of finding center of mass for a very simple system. Now from this situation, if suddenly I take this m2 out, so I am taking the m2 out of the system, then what will happen, whatever is my center of mass, from that the whole center of mass will go into 0, because now if this m2 is not here, so that means only m1 is here, and the center of mass for m1 will be in the center of that object itself. So let us see that it gives us 0 or not. So how to do, like so what do we have to do, we have to subtract this m2 part, so that this r we can get like at 0. So that means what I have to do, so this was my r, that was m2 r by m1 plus m2, m2 r by m1 plus m2. So now if I subtract this m2 r part from here, so that means what I have to do, while doing this, while finding this value, this one, that means this r wala value, I have to subtract m2r from here. Why? Because this m2r, this portion is going out of the system. So what I have to do here, I have to just subtract m2r from here, and as a result you can see that there is no other term. So m2r and m2r cancel each other and my r becomes 0. That means when this system will not be, this particle will not be here, the center of mass will be at a 0 position, and that is true. So that means whenever something is going out of the system, we have to subtract this term which is going out. Okay, so this you have to remember, that we have to subtract this term, that is MIRI term, that is whatever is the donation of that system which is going out, that donation we have to subtract from this. Okay, so what we can say that because, so that means this part is the contribution which can shift the center of mass from a system to up to certain point. So whenever you are asked to find the center of mass if this portion is cut, so you have to, while finding the center of mass, new center of mass, you have to subtract this contribution, that means m2r, or for that object whatever will be that MIRI, let's say. So that portion you have to subtract. So using this what you say concept here, what we will do, we will first do what, let me remove this part, and what we are going to do, we have to find out the contribution because of this YOLO one. So contribution of YOLO one, of YOLO, and we have to find out the contribution for blue one, and then what we have to do, I have to subtract this blue one contribution from that center of mass formula. So if we have to do that, so first we have to find out, so let's say the total mass of the disk is m, but I don't know what is the mass of this small portion, so I have to find out mass because I have to subtract that MIRI term. So what I have to do here, I have to find out the mass. So let's say the yellow one is having mass m. So that means I can write that the density, mass density, is total mass divided by the area, because it is a, what you say, laminar shape. That means it's a 2D shape. So here volume will not be applicable, the only area is applicable. So sigma is the density of this material. Now if this is the density, that means density means the mass per unit area. So let me find out what is the area of the blue one. So area for the blue one is pi r square by 4, because r by 2 ka whole square, so that is pi r square by 4. Okay, so basically this is this, so that's why it is r pi r square by 4. Acha, now this is the area. So what will be the mass of the blue one? The mass of the blue one will be sigma, that is the density per unit area, into the total area, whatever is the area of this what you say, blue portion. So if I just put the values here, so I can see that it will come m by 4. So the mass of this blue one is m by 4, and the mass of the yellow disk is m. Okay, so now this much we have gotten. So let me write out, let me remove this part. I hope you take the notes, or you can go back and see once. Okay, so the mass of this one is this, and the mass of this one is m by 4 we have got. Now what we have to do, we have to first see that your new location, when this blue portion is removed, the new location of your center of mass will be summation of MIRI. So the yellow, for the contribution for this yellow one is m into 0. Why 0? Because O is the initial position. So O position is actually 0 comma 0 position, just like that system which I have shown you here. Okay, because m1 we have taken at 0. So here also it is m into 0, because that is the center of mass for this whole disk is at 0, plus, oh, now the question, this is not a plus, because that portion I am taking out. So initially it was at plus, so let me do plus, and I will see that the, what you say, like, see, if this portion is not cut, if this blue portion is not cut, then this disk is a whole system. Now we know that for a disk the center of mass will be at 0 position, right? So center of mass will be at initially 0 position, that means at center. But from that portion, now this portion is cut, so the contribution for this blue portion I have to take out. So this will be m by 4 into, now see what is the distance from the center of mass, this is r by 2. So the distance is here r by 2. Okay, and divided by m1 plus m2. So this will be m plus m by 4. Okay, now this portion I have shown you that this portion is not this portion is same, but that portion we can take it out. Acha, so now if we do this, so that will be 0 minus mr by 8 divided by, now this will be how much, this will be 5m by 4. Okay, so this will be 5m by 4. Now you can just cut out m and m, this 4 will go. So if you just simplify this, if we just simplify this, and this mm will go, so my result will come, so this, so the result will come r by 5 minus r by 5. Oh no, I have 2 down here, so 2 will be multiplied with 5, so it will be 10. In this case it will be minus r by 10. Now why minus? Minus means it will be in opposite position, like it will not be in this location but it will be in opposite location. So this portion will be, so this much, okay, so this position will be minus or r by 10 at r by 10 distance from the O. So what you have to do, you have to just remember that you have to subtract the portion of what you see, the contribution of the cutout piece. Okay, so you have to subtract that contribution from them. So this was the basic idea behind it. Okay, now let us go and see what will happen to the moment of inertia. Now finding out the moment of inertia is little bit different. The system is same, that means you there also you have to subtract the contribution because of that cutout piece, but here little bit difference is there. So this is the disc and let's say this is my cutout piece. Oh my god. Okay, so this is my cutout piece. Okay, now you see this was the initial position, fine, and the total radius is r. This much is my r by 2. Okay, and now I have to find out. Now I know that the moment of inertia is given by summation of mi ri square. So initially for center of mass it is only ri, here ri square, and this is summation of mi. Now what will be here in this case? So initially we know that the when the cutout piece is not taken away, it is intact, then the for the disc we know that this is the formula for moment of inertia. Half m r square is the moment of inertia if we take the axis at the center. Now this we know, so from this we have to subtract the value of that portion. Okay, so what we are going to do here, let us find out. So again we have to find out the mass of this one. So the mass of we have already seen if this is m, and we can find out mass using density, that m by pi r square, and then we can find out the mass of the blue portion, and that will be small m equal to sigma into pi r by r square by 4. So ultimately it will come m by 4. Fine, so we have seen that already. So that means we know the masses, so this is m and this is m by 4. And now what we are going to do, so we have to do this thing, that means we have to, this was my I final after taking out, so that will be my I initial minus the moment of inertia blue one. Okay, so the blue pieces moment of inertia, so the moment of inertia of the blue piece I have to find out. Now you can directly write it that I know that what is my initial one, that is mr square, minus here you can also write half, then mass is m by 4 into r square, but that is not correct. Okay, r square by 4, that is not correct, because this formula is only valid for the if the axis is at center, but here if you see for this blue disc the center is at O, so the blue disc is actually rotating along this O, so the blue disc will rotate like this, it will not rotate in itself, it will rotate about this diameter. Okay, so about like one of the point at its circumference. Okay, so that's why what you can do, you can use your parallel axis theorem to find out what will be the moment of inertia. So we know that the moment of inertia for blue disc at x, if I take O prime as axis, so the moment of inertia uh, of the blue disc, if I take O prime as the axis, that will be half m by 4 into r by 2 square, so r square by 4. But here the new moment of inertia about O point will be, see the shift. So I told you that the parallel axis theorem is that whatever is the initial, then plus m, that is the mass, into a square. That was the general formula. So I will just replace everything. So I0 prime, that will be your m r square by, now this 16 and 32, and m a square. Now what is your m? M is my m by 4, and a square, what is my shift? R by 2 shift. So you can see here the shift is r by 2. So from O prime, now I am taking the axis as at O, so r by 2 shift is there. So instead of a, I will write r by 2 ka whole square. So that will be r by 2 ka whole square. So finally that will be again r square by 4. Now this 4 and that 4 will be 16. So this you can do, okay, this you can do in your home only. Okay, so now what will be this one? It will be my mr square, 32 will be my LCM, and that will be, so this will be 3 by 32. Okay, so that will be my I0. Now I can do I0 means that one. Okay, so the blue one ka whatever is that. So now I can subtract from my initial one. So now I can use my formula. So my formula for cutout piece is this. That means the new one, the final one across O axis will be the initial one across O axis minus cutout piece, that is B, across O axis. So initial one was half m r square, or I can write like this, m r square by 2 minus whatever is my this one, that means 3 m r square by 32. So 3 m r square by 32. So this so LCM will be 32, that will be 16, and 16 minus 3 is 13, so 13 m r square by 32. So that will be my final moment of inertia if I cut out that piece from the bigger one. Okay, so this is the way of doing this kind of cut out problems. So basically again I'll remind you once that for your moment of inertia and center of mass, in this case, both case you have to find the mass of this cutout piece at first. Then for moment of inertia, the formula is simple. That means whatever was my initial and whatever is my final, I have to subtract. That's it. Acha. Now whatever is your cutout piece ka moment of inertia, be careful, because whatever is that shape, so the axes are different. So now this blue one in this case was not rotating across O prime, it is rotating across O, but we know the formula for O prime. So that's why we have used parallel axis theorem here to find out whatever is the moment of inertia at axis O. Okay, and then we have put the value of O here. That's it. So that's why we can get this thing very easily. So I1 is very easy, not very complicated, but the center of mass one, you just have to remember that the contribution for that cutout piece I have to just subtract. When we find the center of mass for the whole thing, then we add things, right? But when we are going to find the like center of mass after taking out some portion, we have to subtract the contribution due to that cutout piece. Okay, so this one you have to do very carefully because there can be mistakes. Now in this case, if we just add them, what we are going to have, let me see. Okay, no, there will be no. Okay, no, it's fine. So this is the basically theory behind this cutout problems. So it can be such that you have something like this. Let's say you have something like a rectangle, you have rectangular piece, and then from that I have taken out uh, from a corner I have taken out this much or this much. So it was initially rotating like this. So for a rectangle with uh, breadth this and L, the initial, let's say I is 1 by 12 L square plus p square m into. So this I know. Now we have to find out the moment of inertia for this one, but for this one, see, there is a shift because this yellow one will rotate across this one, not this one. So that's why you have to find out by using parallel axis theorem what will be the moment of inertia across this point. Okay, and then you just subtract it to find. Acha. For finding center of mass, again the same procedure. You just have to subtract the, what you say, contribution due to this one. So you have to find out the mass for this one. You have to the whole mass. Let's say the mass is given m. Let's say this is small m. So whenever you are finding the new distance for center of mass, what you have to do, you have to do m1 r1. Now r1, let's say this you have taken 0 position, so this r1 will be obviously 0 again, and you just have to subtract this position, this mass. So this will be, this I have taken big M, no, so this will be big M, this will be small m into this distance, whatever is this distance will be given, this will be given to you. Okay, let's say this is A, so that will be A divided by M plus M. So like that you can do and find out easily. Okay, so this was whatever I wanted to tell you. That's it, and we will discuss this in our live classes as well. Okay, thank you, see you in my next video.